do, and do. Let's make sure we have audio because we can't rely on that anymore. It looks quiet to me. It looks like the microphone volume magically went back down. So like, okay, 4 decibels. Okay, hello, hello, no. 4 decibels apparently isn't any. 10 decibels. Okay, okay, that's probably too many. 7. Decibels are so stupid. Like, I don't understand. It's totally cargo cult that people think they're cool. Okay. I'm going to make a test program. Import basic memory debugger equals true. We're going to have memory is a pointer to void. We're going to have memory is alloc 100. And then we're going to do leak reporting, which I don't remember how to do. Report memory leaks. We could actually not even do that yet. We'll just do this. Easy program, right? Right. Boom. Um, so this is interesting because I think we fixed some stuff about our call stack things, and so we report one too far now. Let's take a look at that. It's called pack stack trace, finder pack stack trace. Okay. Oh, I was literally just looking at it. This is what happens when I play Super Morning-O Bros, is my brain is not completely turned on yet. Packed data. Oh, there is pack stack trace. Oh, but that's like in basic. Okay, so what we really want to do is say like skip the top one. Skip from top is 0. Or I mean, or instead of complicating these, we just cursor up, right? Find or pack stack trace trace.parent. Actually, this is not the right thing to do even. Because we may not have stack traces. Let me just see. Find or pack. That's 1. Here we skip 1. Here we skip. Oh, that's the same. Here we skip 1. Here we skip 2. All right. This is still not great. Because we've got fucking branches. But whatever. Okay, find or pack stack trace. 1, 1, 1, 1, 2, right? Add allocation. I mean, it happens to be 2 all the time. Okay. I'm hungry already. Next. Not parent. I left that in. Okay. That is not what I wanted to see either. Okay, I don't understand. Oh, because this is... No. Okay. Oh, I get it. I get it. Okay, I was confused. We're passing in. Okay, so the reason I was putting 2 was like, oh, we're one function deeper, so we have to add 1. But we're passing in the trace. Okay, and what that means actually is we don't need this. Okay, cool. Um, trace memory debugger no longer prints its own utility functions at the top of the stack. I think this was a recent regression. Okay. If I play Disco Elysium, no, I'm not a godless communist. But no, I never played that game. I don't really want to be lectured by 20-year-olds about their idea of morals. I turn 21 next year, guys. I know better. Okay, so this was good, but it was merely a diversion. Because we should not be reporting this as a leak. We should not. So we have this leak summary. If I recall correctly, this is not just a leak summary now, because it's used for the live heap visualizer. So for every allocation in the address table, we're saying, do we have this? Do we have a summary for this? I'm not sure why we're checking if there already was one. I should have put a comment here and I didn't. But if we didn't find it, we look for a new one. So the address table goes from the memory location to our other thing. To an allocation. We maybe should make this into flags, but you know, um, okay. Here's what we're going to do. We're going to say, was that address table? Yeah. Okay, we're going to say if for a visualizer and I kind of want to take a default struct here. Like these options. The thing about taking a pointer, I could say, hey, they set the pointer to null. Let's just default to some things, but then like I can't tweak the defaults over here. Like I want to have a thing that says scan global memory to, I would say remove leaks, right? Okay, and then scan leaks to combine. Right, and so now, since I'm taking a pointer, I like can't do it. So here's what we're gonna do. Gonna do this shit. Okay, well, this is the reason why I did that. Okay. So now if options, that doesn't make any sense. Okay, now, wait, what? Oh, I didn't do this part. And options.scan global memory to remove leaks. We're going to no check in this for now. We're going to put a call there to a thing. Now, I need to make sure the tests compile. Modules basic, report memory leaks, log memory leaks, etc. Now take leak report options by value instead of a pointer. It defaults to the default struct. Okay, so I might have broken some tests with that API change. Who knows? What are all the pumpkins doing here? Why are there pumpkins? Why is David S. Pumpkins in my stream? Ever since you've heard me state that statically compiled binaries can reap the benefits of security updates, are there current tools for rebuilding the executable file? No, of course not. Why are you asking me? Nobody ever changes anything. They just build old stuff in the operating system, and then the people who originally built it know how it works, and then everybody else is fucking scared of it all the time and won't touch anything. And that's how you get the computers that we have now. So of course nobody's done that. That I know of. I don't know. Maybe somebody's done it. Well, hello to all the pumpkins who have showed up in the chat. Okay, so we did break something. Oh. I didn't, yeah, that wasn't what I thought about breaking. Remember this, when I was going to do this that way? Let's make sure Invaders works. Let's run it. Hell yeah, bro. Yeah, oh, we got firepower now. Dude, we're roasting. We're roasting. Oh, I should have picked that up. Ah, I missed it. There we go. I'm too good at this game, everybody. All right. So that's working. That is a lot like Diablo 4, actually. Do I have any more OS ideas other than no drivers and default? Nope. Those aren't individual ideas. Those are ideas that the operating system itself is more like the control plane, like in the Arrakis paper. And that leads to a lot of, firstly, it leads to a lot of design changes around how the operating system would work. But secondly, it means the operating system is not trying to be every goddamn piece of software on your computer like it has today. So when you ask me, do you have more OS ideas? No. You want to have fewer OS ideas because OSs are like Let me run this while we're ranting. Because OSs are like 1,000 times more complicated than they should be, and that's why we have so many problems. Have fewer OS ideas, please. Please. Have I ever heard about Solid OS? No, I have not. Do I have ideas about the desktop environment? No, I don't care. It shouldn't be a giant piece of shit. That's my idea. How do I author those particles? They're all literally the same particle. Is exposing hardware like NIC to user space, would that no longer be a security problem? Why is it a security problem? Why would it be a security problem? Start from scratch and don't be a dumb... Dude, starting from scratch and don't be a dumbass would solve most computer problems. Most of our bugs would go away. And everything would be tremendously faster than it is. And there's just no willpower to do it. The problem is you can't just have that as a mission statement because a lot of people will disagree on what don't be a dumbass means. A lot of people think don't be a dumbass means be a responsible programmer and rewrite all software in a modern language like JavaScript because JavaScript is so much higher level. And so you really need simultaneously somebody to be in charge of not being a dumbass, right? You need the secretary of not dumbass. And that person needs to be correctly chosen. BSD operating systems are good but not popular. I mean, they're probably better than Linux, but they're Unix, dude. So they're not going to be that good. I mean, again, Unix was a cool idea in 1970. You shouldn't be running it today. But you don't really have a choice. So they would rewrite everything in Rust. No, no, no. There would be like giant religious wars about what programming language. Like all the fucking Haskell people would come out of the woodwork, right? And then all the Java. It would be like something from one of the later Dune books that I haven't read, where all the JavaScript people are fighting all the Haskell people, and Clojure fucking people who are fighting all the Rust people, and there would be like a giant bloody pogrom. There aren't enough small talk people. The small talk people would lose that battle instantly. They would just get run over by the JavaScript people. Rust will fight all and win. No, I mean, the problem is Rust will lose in that battle because they're all like getting their guns out and like trying to figure out how to fucking load it, and then it keeps like not accepting the magazine because the magazine is not being put in at exactly the right angle. And then you try to pull the charging handle and it ejects the round and says, round not correct. And then while all these guys are sitting there going trying to fucking get the thing loaded, they just get shot. That's what happens. Yeah, guns are inherently unsafe anyway, so they wouldn't use them, right? They would only have a couple, like the couple of people trusted for unsafe weapons. That's actually a better point. Everybody else would have Nerf guns. So they would just lose, is what would happen. Okay, so all the tests work. I don't want to take the W on that yet because we haven't really done anything. We're in preliminary still. So do scan global memory. You want to see some cool shit? I guess we could just do this. New functionality, bro. What was this example that I just literally added yesterday? Runtime global data search, that's what it was. I just want to copy my code because I'm lazy. Okay. Here we go. Here we go. Here we go. Called while holding, what is it? Address table mutex. I should have a way to assert that that's held, but I don't. Data segment info. For now, we only scan at alignment 8, but we can adjust this later once we are comfortable with it to scan at alignment 1 to handle packed structs. Okay, so segment pointer size. I don't know why we're doing that, but we are. End is segment.data plus segment.count. P is segment.data while minus pointer size. Okay. While P is let's do this. Okay. While P is less than end, P plus equals 8. Okay, so casted is cast void P. Memory is casted star. And now we've got some memory. So we're going to look it up in the allocation table. What's it called? Address table. if success, okay, we're going to say set is live to false. It's not called data segment info. What's it called? Global data segment info. Get runtime info. Oh. Didn't work. Oh, wait. Marked as non-leaks. That's what we should be doing anyway. Non-leak bytes. Found.index is 0 is what we really want. Now, it's not going to work because the other one didn't work. Let's make sure we get here. Dude, we're not even Cowabunga. There's no Cowabunga happening. Let's make sure our compiler is up to date while we're being paranoid. I think it is, but nope. Okay. Didn't help, but here we go. Cowabunga. Why do scan? Oh, we want not for visualizer, dude. This is what happens when I super morning, oh bros. There we go. Cowabunga. See? Marked as non-leaks 100 bytes in one allocation. Fuck yeah. Okay. So actual leak. Okay. So now we want to assert that there's only one leak and it's 42 bytes. Okay. So we're just going to go over all of these. Count plus equals it dot count, bytes plus equals it dot bytes. Okay. So we're just going to assert count is equal to 1, bytes is equal to 42. The reason I'm doing all this is because we're going to make this into a test, which is when all the people go, is it a unit test? Is it no, it's not a fucking unit test. It's a test for it's just called report. Bytes. There we go. Now you can see what would happen if we got our assert wrong. Then our test would complain. So that's great. What is a non-unit test? A non-unit test is what everybody fucking did for, let's say, 60 years before Hacker News Kids decided that unit tests are a brand new thing that they invented and are amazing and solve all the problems. And all you do is you do a subset of all the tests everyone was doing before, but you call it unit tests and you say that you're a DevOps engineer doing unit tests and therefore you have all the solutions to the world's problems. And then that resulted in the amazing quality of software that we have today. So obviously it's right. I'm having a bowl of cherries for breakfast, except, okay, in America, these are cherries and we just call them a different kind of cherries, right? I don't know what we call them. In Denmark, I was hanging out with my friend in Denmark a long time ago, and I was like, let's get some of these cherries. And she's like, those aren't cherries. That's a different fruit. And I was like, what? Okay. So that, yeah. Some people think it's a different fruit. Most of unit tests just test how things are implemented, not that they're correct. Yeah. that's people misunderstanding the point of a test, but also, I mean, it's what happens when everybody's doing stuff just to check off bullet points, right? Okay, we're going to take the W on this one. Scandinavians differentiate between sweet and tart cherries. I don't know if that's really the difference between these, though. Anyway. Recently had a bug where GCC deleted a valid null pointer check in a single calling site after inlining. All the unit tests passed, those calling sites not affected. Yeah. I mean, talk to the UB people about that, bro. Okay. More recent thoughts on crypto after banks not working? Not really. Again, I don't think so-called crypto solves anything, and nobody's ever. I mean, okay, it's an interesting technical thing to have figured out, right? But that technical thing doesn't solve anything. Doesn't it solve theft of money? No, obviously not. Have you seen how much Bitcoin theft there's been? It's insane. Presume I'd be worried that a malicious app could snoop traffic intended for different purposes. Well, you're assuming that you let people snoop doggy dog um, arbitrary messages on a backplane, and those messages are unencrypted. I think, first of all, okay, here's the thing, guys. I've ranted about this before, but like, your PC at this point has like 37 different computers in it, at least, right? More than that. It probably has 100 and something computers in it. Quite a number of those computers can read the various buses, right? And most of those computers are insecure. And so, like right now, you already have that security problem. So I'm not sure why you're saying this is a new problem, first of all. But secondly, um, I'll just say you should prevent people from snooping bus messages that they should not, right? That should be a fundamental design decision, but that includes not only software, but like other parts of your PC that you don't even understand are there, right? Now, there's various ways that you could do that. You could encrypt the traffic. Um, the thing is, if you encrypt the traffic, that's maybe not good enough because how do you know someone can't snoop the key or whatever, right? So there's various things. I mean, maybe you want the operating system to just, control the receiving of messages. The problem is that potentially could be much slower unless you're very careful about the way you design it. Now, this kind of detail, unfortunately, is not the kind of detail that I have the bandwidth to think about in great, because what's the right decision depends on the consequences of making various decisions various ways. I haven't thought through that decision tree because I'm not making this operating system right now. So I don't know. I don't know what's the best answer there. I feel like there are several good answers, though, that all of which would work. Performance report is crashing on you because Akali is null. Yeah, it's not really supposed to happen. That's a known bug in the new thing. So if you mail that in, we'll take a look at it. If you can mail in a repro, it's super helpful. They can't unbank you with crypto. Yes, they can. Absolutely, they can. And they will. Like, it's highly likely that most countries in the world, unless somebody figures out something really fast, it's highly likely that most countries in the world are going to declare so-called cryptocurrencies illegal, and then they will shoot you if you transmit them. And then what are you going to do? Like, that's the fundamental problem that nobody's solving. Do we already have the functionality to say assert is in mutex lock? I think we might actually have that. I might have put that in. There's a 30% flat tax on crypto in India. Yeah, I mean, that's the thing. Like, this is the fundamental thing that all the crypto people don't answer, right? They're like, oh, it's decentralized and nobody has authority over whether you can get money and all these things. And it's like, okay, hold on. Every country in the world wants to tax your money. So they have to be able to do that. So they have to be watching all the transactions. Either they're watching all the transactions and they'll arrest you if they don't like the transactions, or they're not able to watch all the transactions, in which case they will shoot you if you do a transaction. Those are basically the two options. And this whole community is not coming to grips that that's how it is. Okay? So like if people would admit like, okay, well, it's an interesting technical foundation to run transactions on as long as you figure out how to make them go fast enough, but it doesn't solve these other problems of autonomy and secrecy and privacy, whatever. If people would admit that, you could have a more adult conversation about this stuff, but that's just never what happens. Yeah, and this is one of Casey's points, as someone is saying in chat. You need a system of law to solve any dispute, right? Like, you need to be able to solve disputes, or, I mean, like, what we call money is in um, part of the, what would you call it? Part of the reassurance that people take in the fact that money is real comes from the systems around money, right? For example, the legal framework around it. And yeah. If you don't have that, your currency is going to be regarded as inherently very risky. Um, but B, again, like, as soon as you have non-trivial value transacting back and forth, government entities will engage these mechanisms anyway, right? They'll be like, dude, you've got all this Bitcoin. You owe this dude over here $17 million, and you're claiming you're broke now. You declared bankruptcy and you're claiming you're broke, but you've got all this Bitcoin. We know you've got all this Bitcoin. Pay the dude, right? That's what the legal framework is going to say. And then either you pay the dude or you go to jail, right? Like, those are the options. You can keep your wealth secret with Monero. Yeah, but like, then you're again. So, and if it's possible with some system to actually keep your holdings secret, then you're just a criminal anyway. And you're choosing to live as a criminal, which, I mean, you're not probably today in a lot of places, but under the hypothetical case of which I'm speaking, in which laws are passed to make this illegal. Well, no, it's already practically illegal anyway, right? Because the IRS wants to tax you. They require you to declare your income. If you don't declare your income, you're already breaking the law, right? So in the US, it's already illegal de facto. In most countries, it's already illegal. So, like, what are people even talking about? You know what I'm? This is what's so frustrating about. Like, what are people even talking about? You'll be criminals for eating more than 10 ounces of beef a month or whatever. Yeah, no, true facts. That's coming to Europe first, though. President Thunberg will declare the beef limit. Given that we're all going to be criminals anyway, it's time to say no. I mean, maybe, you know, maybe, but there's different ways of saying no, and some are a lot more pleasant than others, but it sure doesn't seem like people care enough to do that. You know, I mean, this is the problem. I was listening to an interview last night while I was driving home, and this guy said he was very optimistic because we have 100 million people in the US who are qualified to be president, you know, legally, which is a tremendous talent pool. And yet, we have the two leading candidates that we have, right? Like, square those two facts. It's just not. It just doesn't make sense. You've already had your bank account frozen once. Yeah, dude, all the bank account freezing stuff that's happening is, I think, really terrible. The fact that people aren't getting more angry about that than they are is a problem because it's only going to get worse. What's the account freeze thing? A bunch of people lately have had banks just freeze their account for arbitrary reasons. Probably due to anti-money laundering laws, which are bullshit anyway. Um, and the thing is, as long as it's a small percentage of the bank's customer base being affected in this way, they don't really have to care. So, yeah. Now you literally have a stack of cash in your drawer. Yeah, I may have to do that just as a preventative measure because I don't. Yeah, it's ridiculous. It's crazy. Okay, let's get back to programming though. So, I think I was going to take the W so far for this. Okay. Um, we're going to make this an incomplete. Let's actually try Sokoban with the memory debugger. I haven't done this in a while. Use memory debugger leaks. How do we turn this on? Leaks. All right. Not leaks. Leaks. All right. So we're running a bit slower because we've got the memory debugger turned on. But we're spending all this time compiling shaders still for some reason. Okay. Look at our fixed shaders for mirages, man. All right, quit. Oh, I should have put that, redirected that to a file. Oh, no, we have enough console. Okay. So we've got our leak report. It makes sense. The top function is good because remember we changed that. Marked as non-leak, 146 megabytes. If we get some more elaborate way of marking as non-leaks, we could maybe categorize like, oh, these are accessible from globals or whatever. So the next thing I maybe want to do is pool together leaks in the following way, right? We'll also put this in our test, or maybe we'll make a separate test for this. You know, if you have an array that you leak, and the array is full of things that are also allocated, it's a little bit redundant to report all those leaks. It's noisy and it makes it hard to understand because, you know, probably you just didn't call the function that frees that array or whatever, right? And that function would have taken care of the members. And so in the same way that we just hierarchically noticed that this allocation was like reached from the global thing, you want to notice if allocations are reached from each other if it's not a cycle. You don't want to falsely mark a cycle, right? Cycle killer. Qu'est-ce que c'est? Baby. So we're going to do something for that as well. But first we will take the W. Port memory leaks. Now counts memory reached from globals as non-leaks. Wait, this is the wrong. I'm checking in the game. That is not right. I put a period on that comment. Is that really the only change? Yes. Let's put this in the change log. The memory debugger in modules basic now uses the global data info to mark allocations that are still reachable via global variables as non-leaks. This should greatly reduce noise in the report. This can be disabled. What was the thing called? Leak report options. By a setting in leak report options. This should greatly reduce noise in the report and reduce the need to do so much calling of this allocation is not a leak. Okay. Cool. Boom. Leaked in M. Wait, what? Where's the M? Memory, the memory debug. Uh-oh. That'll get me canceled. It'll get me canceled because I didn't call it chest debugger. Okay. All these tools and standard libraries are what you need daily and not present in C and C++. I mean, it's basically true. However, I mean, you can get this kind of tool for C or C++, but it's not standard. And then, you pay a bunch of money for it maybe, or you get a free version that's not very good and doesn't really work. And either way, they're really hard to use and they slow your program down tremendously and all these things, right? So part of the point of us building these things in the way that we do is they are simple and easy to understand. Like you can go read the code for the memory debugger. It's 1,000 lines. How did 1,100? We just added some, right? It's like it's not that much. You've probably done homework assignments that are bigger than this, right? This is not just leak reporting. It's also like live heap visualization. Yeah, it's true. Also, the tools don't work with each other. That's very true. Very demotivating. That's also very true. Why do you think I went and spent all this time making this programming language? It's because I was so demotivated is a good word. I was so demotivated by the state of C++. Okay, any questions, technical questions about what we did? I want to warm up some tea water and then we're going to do the next phase of this. If I mean, I didn't quite get a full amount of sleep last night, I think. But I woke up, I did this thing where I woke up and I had energy, so I sat down to program, but like my reasoning brain is not in its best place right now, but we're going to try to do the next part anyway. Questions, questions. What's the plan of doing ASM or ARM64? Are you going to allow? Yeah, I mean, you probably want a different. Um, I don't think you want to try to unify all assemblies into some glorious global syntax. I think that's mistaken, right? Like you end up with the weird GCC assembly syntax kind of thing that nobody likes. So I think you just have essentially functionally a different assembler per CPU, and then you just try to make sure the integration with the rest of the compiler is factored out from that and doesn't require a bunch of extra work, hopefully. Does this help with leak detection for custom allocators? Yes, that already all works. None of this is built into a specific allocator. So the memory debugger cost is a thing a GC language always has during runtime, not just on demand in local build. I mean, it's worse than that because we're only paying that cost when we generate the report. We're not doing any of this tracing in the middle of runtime, whereas a GC language is doing that in the middle of runtime. Do we have smart pointers? Smart pointer is a propaganda word. I don't accept that term. You have to first explain to me what's so smart about smart pointers. Isn't that interesting how much of making your programming thing successful in the world is just propaganda and mind control? Like you make this idea called smart pointers, and then because people want to be smart and they don't want to look dumb, everybody says, yeah, I like smart pointers. Whereas if you had called them smelly foot pointers, people probably wouldn't want to use them really, right? So keep that in mind. Okay. So here's what we want to do. We want to go through all the allocations. And we want to we want to scan the memory. And we want to scan the memory much like we do here. Okay. Very similar. And just do a different thing when we see a pointer. So we want to do this scan. We want to look things up in the address table. When we see them, we say our allocation is contained within this other allocation. Unless Unless what? Unless we make a cycle, right? And so, usually there are ways of doing this, right? So for example, when you say that you're contained in someone else, they have like a depth value. And then you set your depth value to their depth value minus 1. Okay? And then how does this go? If they come along later, because we don't know what order we're going to encounter these allocations in. So if they come along later and we decide that they're contained within someone, we look up the depth value of that. It's like I guess the rule would be you can't change your depth value if somebody has set their depth value based on yours already, right? Something like that. Does that make sense? Does anyone have a better idea how to do this? But so then you would say, okay, it looks like my pointer is contained in the memory of this other guy. Oh wait, my depth value is locked and his is deeper than mine, which would mean we would create a cycle if we were to do this, right? Something like that. We need to remember, before I get too much into this, we'll just answer more questions for a minute or two, because I put a lot of tea in the tea, and if I steep it too long, it's going to be really bad. So we have to make sure that I don't get absorbed. And if p is less than end, isn't that ignoring end? Yeah, you're right. And I made exactly that mistake in um, in the example program, right? Um, and then I fixed it. It's less than or equal here. So you're right that it should be less than or equal. Nope, not that. There we go. I made literally exactly the same problem. So you would think that by copying that program, I would have avoided this, but it didn't work that way. Okay, so here's the thing, is we want to have all this tracking data on, I'm really hungry. I'm just eating all these cherries. We want to have all this tracking data essentially for each allocation, but I don't want the data structure for allocations to be much bigger because we're manipulating all these at runtime all the time, right? So if the data structures are bigger, that's incurring more of a runtime cost all the time as your program's just running. And we don't want to do that. So we can just bring this extra data along at the end and have it in a hash table. And That's slightly more complicated, but probably fine, hopefully. We'll see how it goes. Okay, so we're going to do this the same way. Scan global. We're going to say do scan leaks to combine. All right. A little bit copy pasta from this, but also maybe not that much. So we're going to let it slide for a bit. Let me get that tea. Okay, we got our golden monkey. It's very good. Okay, nobody has any questions. That's fine. So, we are gonna go for everything in the address table. Okay. Well, if the allocation is not live, we skip it. Otherwise, we're gonna look at it. We have a size. Copy pasta. All right, so P here is just going to be memory. Okay, and let's get our pointer size back. All right, end is P plus allocation.size minus pointer size, while P is less than or equal to end. This really should be pointer size. All right. if we're going to go out of our way to do that. All right. We're going to do this. We're not going to call this memory because we've already got a memory. So pointing to. All right. And actually, so we might abstract this out into a macro or something at some point. Anyway, we're looking in the address table for things we are pointing to. If success, if found is equal to memory continue, right? Actually, so found is going to be the allocation. Pointing at ourself is fine. Okay. Otherwise, like I said, we're going to put this other stuff into a different place. We're going to have something called like a leak combiner record or something. Wow, this tea is so good. I made it just right. It's my favorite. Okay. So we're going to say find or add in some table, right? So this is probably going to be on the leak report. Table from a pointer to void, I guess. Again, we'll use the memory just like the allocation table. Leak combiner record. See the comment on leak combiner record. Okay. Leak combiner record is a struct, and we're just going to say leak combiner records are stored in the leak combiner table, which is parallel to allocation table, alcoa, allocation table, and just stores some other stuff. It would be simpler to just store that stuff in allocation, but this probably would noticeably increase runtime overhead as you know, as we would be manipulating more data on each memory access. Maybe in practice it wouldn't matter, though, and we should simplify this out. Let's just start looking at how much we want to put here, right? So we're going to have allocation or reference depth U64 used to avoid, let's make it S64, used to avoid cycles, because if we mark everyone in a cycle as being contained by someone else, that's not very good. We will never report a top-level leak for that cycle, even if the whole thing leaks, I guess. I mean, I feel like we're making it harder than it is. Okay, so we're going to have here, again, we're going to have count S64. How many other leaks are pointed at by this leak so we don't count them separately? Child bytes. Ibid but for bytes. Okay, so do we need anything else besides this? I feel like maybe not. This doesn't seem like that much data. I mean, this is like 9 pointers large. And this is another 3. I mean, it's non-trivial. Yeah. Okay, so I can just set the allocator explicitly on the table. Leak combiner table. Okay, so let's just say combiner is the address of report.leak combiner table. Allocator equals pool allocator proc and the reports pool. Okay, we need to pass this. And So we don't have the report yet. We're going to put it up here. Report. All right. Just making sure we compile. Great. We do. So, okay. Now we're going to say find or add. Okay. We're going to say combiner record is find or add from combiner. Oh, never mind. Pointing to, right? Okay. Okay, hold on. So we're in a thing, and we are pointing at another thing. All right? So A points at B. What we actually want to do is get combiner records for both. We're going to do this once. I'll do it here. So this is a, did I call it combiner? Leak combiner record. A record parent is a leak combiner record. Okay, so we go through, we have the parent and the child, okay? If record parent reference depth is equal to -1, is 0. Wait. Yes. And then, I don't know, like if the child dot reference depth is equal to -1. Otherwise, we already added this child's bytes into some other allocation. You can easily point at an allocation from multiple other allocations. So don't double count it, please. Okay. If the reference depth is -1, okay, I need to think a little bit more about this, but we could actually put in this leak combiner record see, it's good that we have this data in its own place because I'm not going to feel pressured to keep the data super small, right? My bytes were combined into this parent. Okay. Right? Is it memory? No. Wait. Yes. Now, record parent dot child count plus equals two things. Let's call this child allocation. Wait. This is pointing to. This is child allocation. Okay, so child allocation dot count plus also anybody that we aggregated from this particular node, right? Plus record child dot child count, and then the same for bytes. Okay. Okay, this is annoying the way I'm doing this. I want to stop and think for a second. Can I clean up chat a bit? What is wrong with chat? I mean, it has nothing to do with being a good programmer in chat, but I mean, you can't, it's just what people do. You know, what you do is you just let people talk about what they're going to talk about, and then when you get sick of it, you just go become a hermit and don't stream for 6 months. The end. Okay, here's the problem. We are visiting these nodes out of order. So my parent record may already have another parent, right? So I'm not taking care of that case, right? And then, so what we need, like the root parent. We need to put things in the root. What's the root? We get the parent. I mean, the thing is, we're going to cursor up, and this may be slow. While cursor dot okay, we don't necessarily want to add our attribute, our memory, to the immediate parent, because that parent may have already been attributed to someone else, and so on recursively. So we cursor our way up to the root. And we have a speed improvement for this later. Okay, so now parent is table find. Combiner for this. Assert found is not null, or found, it's a Boolean. Because if this field got set, it had better be in the table. This is turning into lots of code already. We're at like another 100 lines of code. Jesus. But it is in service of a higher quality report. Okay. So we find it. We've added 200 lines to this today. We assert that we found it. Cursor equals parent. That's basically it. Okay, we have another problem. We have so many problems. We have, I will explain what this badge is here in a second. I just want to finish thinking through this. Okay, so now we say record root is cursor. Let's just do this. Let's do the assertion. If it's -1, we assert record root is equal to record parent. And I think find or add, newly added, yeah. So we can assign this, assert newly added. We're just making sure that we know what's going on because it's complicated. All right. Now, we have a problem, which is we are adding two things to the table. And we're taking pointers to them, right? So it is possible, so that we're using this table. There's different ways you could use a hash table, right? You could store into it pointers to data that are allocated somewhere else, which is what you do if you're a Java programmer or a JavaScript programmer or a Haskell programmer or all these things, right? You're afraid of values if you're one of those programmers. But values make your program run 1,000 times faster, right? So we're not afraid of them, but they do introduce problems sometimes. The problem here is I want to keep this pointer, but then I want to enlarge the table down here. Okay? So we need to make sure that this is not going to reformat our table. Yeah, if the hash table gets full, then we're going to move things around, right? And if we move things around in this call, this becomes invalidated. All this work that we did. Could you keep it as an index? An index and a pointer are the same thing. Yes, we could do that. It is a solution. However, it's actually more complicated. What we're going to do is we're going to say explain table ensure space for two things. Now, does this function exist? I don't think I added it yet. Let's see. See in table add, we call expand. That's literally the only call. All right. Table ensure space. Call this if you want to be able to add items, number of things to the table without the table resizing in the middle, useful in cases where you want to add multiple items to a table inside one block of code while keeping pointers to those items and wanting those to remain valid. Okay, simple function. Modules basic. Added table ensure space so that you can deal with multiple hash table entries by pointer at the same time. All right. So ensure space for two items so that in the case that we allocate both in the block below, we don't end up in a situation where the first one invalidates us, or the second one invalidates the first one. That's all. Can you make a hash table backed by a bucket array? No, I mean, that does solve the problem. Like anything that lets us use pointers or indices or a bucket array locator or anything solves the problem. It's just I don't want to solve the problem by indirecting to other memory. I just want to do it this way, right? That's all. But yes, you could do lots of other things. The position in the hash table doesn't matter, as far as I know. I mean, am I missing something? But where it's stored in the hash table doesn't matter. We just need a pointer to the record that is constant. Has anyone ever seen bucket arrays with POW2 sized buckets? I have not seen that. I'm sure such a, like, basically every data structure exists. so I'm sure you can find that. Or maybe not. I mean, sometimes there's new ideas. Okay. So we've got our parent. I mean, this code could be shorter than it is. It's just I'm asserting and stuff, right? So it is what it is. All right, so we get the child. Okay. We're gonna mark this. This does not invalidate record root because space is ensured. Like, it's just useful to do this kind of thing in your code. Just like, even instead of just vaguely explaining what's going on here, like, look, there's a tag, there's the tag, like, boom. I almost want to make this kind of tag like a first-class programming language concept that says these lines of code are tied together. We might do that at some point. It could be fun. I just don't know exactly how that would go. Okay. This is not right. I mean, this is, okay. Having this cursor variable as a temporary was a little bit clean when we didn't also need to track this. But now that we need to track this, we're just going to do this. Okay. So we do that. Here we go. Um, this is kind of wrong, this reference depth thing. Because okay. I think I need to move this. Down to here, which means we don't have most of these variables. Dot reference depth is equal to -1. Assert root memory is equal to memory. Okay, so I still haven't thought all the way through this. So how, right? We're not avoiding the how are we avoiding the cycles? This is not quite right, because here we're going to set this to 0. And then if we did the child first and then we get to the parent later, because it's set to 0, we're not going to do any of this. So that's not good, right? And in fact, I don't know. We don't have record parent here. This doesn't even exist. So, like, do we need to track? the depth all the way down the chain? I think we do. Which means we need fucking record parent to stay alive. This is where I'm a little too tired from not getting enough sleep to think clearly. Some sort of simply... Dude, we're not going to do simply connected components. Okay, here's the thing. Detecting simply connected components is a harder problem, I think. Maybe it's equivalent to not making a simply connected component in the first place, right? Like, you can not make a simply connected component simply by flagging things you've already processed, right? Now, the thing is, that's not quite what we want to do, because we want to make the maximal chain that is not quite connected. You know, like 2 chains, we want to make max chains. Max chains. It's like max headroom, but with chains. It is a, you know, it's basically the same thing as you think about when you're doing simply connected components. It's just, it's a little different. So I feel like we kind of want 2 different things. We want to know what's the depth. All right. But here, we could just have a flag called already attributed. We could say if it's already attributed, okay. We need to decide if we attribute it to this root. Okay, you know, this thing that I'm doing doesn't actually really work. I think. I might have to get out a piece of paper and scribble on the paper. Because the thing is, if I make different chains, maybe I should get a simply connected component algorithm. Like, if I make different chains with these depth values that are increasing, and I see one, I don't really know if it's mine or not, right? Which is kind of ass. One thing we could do, okay, there's 2 things. One is just to make this code function correctly, but maybe be a little slow. And another thing is to make it be the good version of itself, right? So to make it function correctly, but maybe be a little slow, what we could do when we attribute to a parent, or when we want to attribute to a parent like this, we could just say, we could like do the reach around and say, does this go all the way back to us, right? And we could skip that scan we could say, um, if um, right, someone already attributed to us before we got here, so do a scan for cycles. We don't even have to do this yet, by the way. Like, let's not make it too hard. Like, cycle detection is a feature that we must implement, but we don't have to implement it to make the non-cycle accounting there and like function correctly. Yeah, so this is a case when I was making it too hard. We should just get it running before this. I'm also hungry. All right. So we're going to verify. Okay, bool. Oh, cycle detected is false. We're going to call something to detect cycles. If cycle detected, then I think we just continue. I mean, our code is big. Um, okay. So maybe we're not going to have this depth value for now. Maybe we'll put it back. Simply connected component stuff definitely uses that kind of a thing. We could go refresh ourselves on those algorithms when we do this part. Um, I guess you could do it incrementally, and so it wouldn't be any extra cost. Okay, so if we have decided that we're not going to make a cycle, we're not tracking depths right now. This is root memory. And then the root gets the accounting. All right. Record child already attributed equal. Well, except we don't need already attributed because that's this. Duh. I'm really hungry, guys. Oh. Table ensure space combiner, comma 2. Okay. Cursor, I changed the name of that. Oh. With table find pointer, we don't bother to return a found argument because the pointer would be null in that case. Okay, child allocation dot count. Oh, it's just 1. Dude, bytes? It's called size. Okay. Here's the thing. Our reporting doesn't say anything about this. So when we do this, we're going to cowabunga. We're going to go print. This could get messy. And then if this is at least firing and not crashing and all these good things, then we can think about reporting this. Wait, did I build the right one? Yeah. It just started up real fast, like. Our shaders are all cached or something. I don't know. I think we're infinite looping, guys. Attached to process. That's something JavaScript developers have no idea what it is. I bet it's a stupid infinite loop. What's going on? Why is my threads window up here, bro? Ain't you supposed to be lost at sea, bro? So I'm confused because I think this should be happening in the main thread. This doesn't seem like my problem. Let's just run this again for a second. I mean, maybe I like corrupted. Oh, no, we just took a long time. Because we're printing fucking cowabunga a million times and the Windows console is really slow is probably what it is. So this is greatly consolidating our leak report. But it also seems like it's this report. Oh. No? Let's do this. This is important. Okay. Oh, yeah, guys, this continue is going to cause us to infinite loop because our advancement was at the end. Did we make that mistake here? No, let's do this here as well. to Future Proof. You know Future Crew, when they make demos? This is Future Proof. We also make demos. Okay, so we cowabunged a bunch. We're still not exiting. See, I don't know if this was a different bug introduced into Sokoban. Let's do this. When we return, let's say print gnarly dude returning. So that I know if we successfully executed all this or not. Future Crew is now Remedy. Is that true? I didn't know that. I didn't know that piece of trivia. No, we are infinite looping somehow. Why didn't I see that? Oh, fuck. We somehow made a cycle. Oh, because I didn't put the cycle detection. Remember when I said, oh, we don't have to do cycle detection. We'll do that later. Okay, but then this part will infinite loop. Welcome to later. I know. All right, let me think about this for a second. I kind of want to make more tea, but I also want to be able to sleep an extra hour after this. Boy, listen to those fans go. They really like infinite loops, those CPU fans. Okay. Yeah, we just have to, we're just going to do the dumb thing here. Okay. Remember when I said cycle detected? Does wait. Let's think about this for a second. So we have the root of the chain, right? We have the root of the chain. We're about to link ourselves into that chain, and we haven't linked to anyone yet. So the only case in which we make a cycle is if we are the root, right? Am I being an idiot here? What? No, well, not if we are the root. If, well, yeah. Wait, but we already discount that. I don't understand how a cycle happens. I need to go to computer science class. Does anyone want to clue me in on what I'm not thinking of here? Right? So we've got by definition, record root has null for this member because we did this. Okay? So the only time we should be able to make a cycle here is if we are record root. Which I thought I had been checking for, but now in retrospect I realize maybe I wasn't. So we're going to see if this assert fires. If it does, we're in luck. I guess that makes cycle detection much simpler. Ta-da! Okay, that's great. So now when we generate the report, instead of doing all these cowabungas, so here we have some giant array pointing at a bunch of leaks. Now, this is sus because we're combining up 300 megabytes of stuff. But our total leaks are 2 megabytes of stuff. So that's something is going wrong here. Okay. How are we getting 300 megabytes of stuff? I'm doing something wrong, probably. Well, we could actually move this condition, right? It's less obvious, I guess, but we could say if root memory is equal to pointing to up here. But it's fine. It's fine to do it in here, probably. Let's get rid of this weasel word necessarily. Get rid of weasel word out of comment. Now, it's 9:45 a.m. I've already worked 2 hours and 40 minutes. Today. That's more than most people work in a day. Although a little bit of that time has been spent on rants. It's fine. There's a cutoff comment in line with child allocation is live. What? What? Oh, Yeah, if we are pointing at a thing that's been freed, no worries. That's all. That's all we meant to say there. Okay. So, we add some memory. What am I doing wrong? This might be the time to take a break and just come back refreshed to debug, or it might be the time to just look at it for 2 more minutes and see the thing. It's hard to know which time it is. Hard to know which time it is. Find or add. So we check this for is live up here. Like, don't scan it at all if it's not live. Let's look at make leak report to see if we're missing something. I mean, I don't see anything weird here. I don't I don't see anything weird here. Let's just put more info. Look at all these. Record root, record child, one. Oh. Is there some way in which we're massively overcounting because of this? I don't think so. Rio chord child. Should have redirected that to a file. These are literally all the same root. Oh, you know what? We're not checking for this allocation is not a leak. All right. Okay. Yeah. If it's not considered a leak because it's been explicitly marked as such, then we shouldn't be doing this at all. Duh. Duh. Hey, look, it was a lot less. Okay, we're no longer 300 megabytes. So this seems kind of reasonable. Like I'm not adding these numbers up right now, but see, this is useful. It's like we took 66 sub leaks and put them into this one master leak. Okay. Um, so when we do this, Let's cut this down a little bit. Again. So now we won't report that as a leak. Now, so we had 9159 allocations. I don't know how that depends on how many frames we ran. No, that's not allocation child. Is it child allocation? It's called child allocation. See, I prefixed in one place and suffixed in another place. That's something we should clean up later. What is going on today, dude? Dudes in high school show up and think they control. Well, it's a lot fewer bytes. Didn't we have way more bytes last time? Two megs. 2 megs of leaks. Now we have 8. It's not a controlled test. You can see the number of allocations is actually higher. It's not a controlled test with the same conditions. What we're going to do is we're going to make a test for this later. I'm just sort of running this to see if it's reasonable. Reasonable output. Okay. $64 megs? It's 64K, dude. What? You think Bill Gates even imagined 64 megabytes? It was 640K, actually. 640K. Um, well, I think it's time for me to take a break and finish having a real breakfast and waking up and stuff. But this is good progress. So the next step in the progress is going to be to say, hey, man, um, when we do this report, we want to say, hey, it's this many bytes, but then we combined, like, we want to report the size of the actual allocation because that's important for understanding. But then we also want to say, okay, but there's a total, we combined into here all this other stuff. And the thing is, we already have this grouping facility, and that's grouping by call stacks, right? But this one is grouping by, like, do you point at stuff? And should those be the same grouping mechanism, or should they be different? Like this is an important question that I want to give myself at least a little bit of time to think about before I come back and do it. As you can see, this reporting it's already sorted. Maybe the grouping says these things were grouped for this reason or something. I'm scrolling up. Let's scroll all the way up. Okay. These are our biggest leaks. We can get rid of the gnarly dude now. All right. These are our biggest leaks. Grouped from 28 stack traces. Yeah, see, so we report this. It's like if I do the grouping by what you point at, and then the grouping by stack traces, we could end up doing all this. I think that makes sense as a way of doing it. See here, like we have this really cool report where it's like, look, here's a stack trace. Actually, it's 4 stack traces where from render base frame, we have 4 different calls to alloc. Right? Let's actually, it looks like this is an intermediate. Let's see. I think we're skipping over intermediate functions. If we're not, we don't need that ... But I don't want a rat hole on that right now. Like 632, 646. Oh, it's different, right. It's different call paths that all went through stuff that ended up in alloc. And we told it to group this way for some reason. Anyway. How is new shader? $54K. I guess it is. Like, we have a lot of 54Ks. So struct shader must have a lot of big arrays in it, basically. That's what we're saying. Okay, everybody. I'm going to go do some other things that I actually need to work on today during the actual workday. And we'll finish this up a little later on. It's just, I think, so we haven't verified that this detection is correct. But maybe it is. And we will write tests later to verify that it is. So there's 2 things. There's testing it to make sure it's right, fixing it if it's not. and then having the reporting tell us, because we've detected what points at what else, but this reporting doesn't know anything about those data structures that we made. So we just want the reporting to also say things. All right, chat was especially insipid today. I hope you're all proud of yourselves. That's what happens when I stream during Europe-friendly times, right? I think that's what we're learning. We all know that all the programming actually happens in America. So when you stream at Europe-friendly times, you get people talking about GitHub stars or whatever people were talking about today. All the kids from after school. All right, thanks everybody. We'll see you later on.